In this section, I'm going to introduce to you the master challenges and the design briefs that we find in our lesson plan PDF. I'm going to start by picking up my iPad, my tablet, and I'm going to talk about the two master challenges. These are activities that require the user to learn and be confident with multiple robot educator tutorials. They are used, and they can be used, to assess student progress. The materials can be flipped as well. We can start with a master challenge, and if we need support, we can use the lesson activity stroke challenges to learn how to complete that master challenge. The one I'm going to show you today, well, the objectives for this master challenge is that students will be able to navigate their robot around a 4-bay turntable-style parking area using a combination of point turns and sensors. After completing this challenge, students will be able to use angles to predict the final position of their robot and compensate for any factors that may affect the accuracy of the gyro and colour sensors. So let's talk about this challenge in more detail. It's called the Turntable Challenge, and it requires students to be familiar with the stop at line and stop at angle lessons in the Robot Educator tutorials. What this is, though, is a great programming and math activity, as it gets students to predict and then test what angles are required to park their robot, their model, in the 4 bays. Now, just move over here to show you. Now, the students can make the challenge map for themselves with ruler, protractor, and some tape. This is a fantastic math activity in itself, but they can also print out using an A3 printer, and also they can, if they've got a plotter at their school, they can print this out on a large piece of paper ready-made. I much prefer the make it yourself version because we're using and applying a lot of our math skills. This material is available as a PDF download, and you'll be able to find that on the LEGO Education website. So, by the end of this session and end of this challenge, students will be able to use both the colour and gyro sensors, and I will show you this in a moment. They'll be able to correctly predict the angle required to park the robot in each of the parking bays, and then they'll use this blue line here to stop forward movement. They will be able to compensate for any factors that may affect the stopping position when using the gyro sensor, and they should be able to work cooperatively to solve the tasks. Now, I'm going to have a go at doing this, or doing one part of it. It will require me to look at the lesson PDF and show you as well, but let's have a go at the first part of this master challenge. So I'm just going to move over here with my tablet, and I'm going to load up my teacher support and the lesson plan PDF. And what I'm going to do is scroll all the way down, I think it's about page 21 or page 22, to the Master Challenge 1, called the Turntable Challenge. In fact, it's page 20. And I've prepared it, I've printed it out. I've only got 2 parking bays here, just because of my space, okay? But obviously you can see here, or you saw earlier on the board, that you've got 4 in the activity. So here is this lesson plan here, my master challenge, and one of the tasks is to predict where a 45-degree clockwise turn will end you up, which parking bay. So let's have a go at doing that. So if this is going to be a 45 degrees clockwise turn, clockwise is this way. If it's 45 degrees and then I drive forward, we should be parking here. So we're going to have a go at doing this activity. So what I need to do is start a new program. Click on close and click on close. Start a new program. Check to see if my brick is connected. It's not, so connect my brick. And in a few seconds you'll see Hawk appear. That's the name of the brick I've been using. And we connect up. And the first thing I want to do is do a clockwise turn. So I bring in my move steering block, and because I don't know how far to turn, we're going to use a gyro to do that. I'm just going to turn my robot on. and we're going to give it a clockwise turn. There you go, you can see, you actually see it, the actual arrow moving into a clockwise turn. And then we're going to bring in our weight block. We're going to change the mode to the gyro sensor. And we're going to look for a change of 45 degrees. So if I click on the number, on the value, I can type in 45 degrees. My robot should turn. Now, real good teaching point here. If I slow down my turn, the gyro should be more accurate. So I'm actually going to change it from 50% right the way down to 10. There we go. And we should have a nice slow turn. Once we have that nice slow turn, what we want to do is stop our model. So we're just going to tell it to stop. And then we're going to drive forever until we see the blue line. Once we see that blue line, we're going to stop. So again, notice I'm just sliding my program along to the left, so I've got more room. We're going to drive forwards. We're going to drive forwards forever. We're just going to drive on or turn on until we see the color blue. So we bring in our weight block, change the mode to color sensor, and we're going to compare the color, and I'm looking for blue. Now by default it switches to red. I just need to turn that off and select blue. And finally, what do we want our robot to do? We want it to stop. So we bring in our stop or off. Okay, now you can see, just squish that a little bit so you can see the whole program. That's our program. Let's see what happens. So I'm going to hit the play button and let's see what happens here. Wow. And what happened? Now, one of the things that's really important with the students is to work out what happened, or to work out why that's happened. Now, two things to check first of all. Remember, we need to check software, and it's in one of our learning objectives for the students, is to work out what happens when the software goes wrong or whether the hardware goes wrong. So let's just do a couple of things to check. Has the gyro drifted? I look at the bottom of the screen and I see that it hasn't drifted. Okay. Now I then need to check my software. So I'm just going to check my software and just make sure that I've checked the gyro to look for a change of 45 degrees. Yeah, that should work as well. So what I'm going to do is we're going to test it again and see what happens. So I'm going to hit play again and we should see what happens. So here we go. Okay, that was a better result. Now we get the students to analyse what's happened. Now, one of the things about a gyro is sometimes it doesn't turn a perfect 45 degrees. Maybe my motor wasn't going fast or slow enough. So we get the students to do a little bit of debugging and work out what's not gone quite right. So, two things we can try. Let's slow the motor down even more to 5%. And also, we saw it turn a little bit too much. So let's just change the angle of turn, because there could be 1 degree of inaccuracy here, to maybe 43. Let's see what happens now. Okay, and this is an important learning objective for the students, to be able to work out and solve these problems. Try again. Fingers crossed. Here we go. Nice turn. Off it goes. Perfect stop. And I predicted it would be going into that parking bay. Really nice activity, lots of math going on here, lots of measurement going on, lots of problem solving, especially when things don't go quite right. The students have to work together and problem solve and work out whether it's the hardware, the software, and then come up with a solution. It's really nice activity. This is one of 2 activities in this Master Challenge. Brilliant for the students. Now, moving on finally to the design brief challenges, and I'm just going to bring up my material here. To go to teacher support, load up the lesson plan, and I'm going to scroll down to the design briefs, which would be around about page 2021, a bit further actually. There we go, so page 24, okay? These design briefs are a series of activities that get our students designing their own model solutions. There are 4 to choose from that we've created. Build an alarm system, Get a robot to dance on the table. Fantastic if you get 3 or 4 doing a line dance. Absolutely looks brilliant. Get a robot to come and greet somebody. And also, final one, build a robotic sweeper to go and clean your kitchen floor. One of the things we really hope, though, is that you design your own solutions as well.